Check something real quick. Have I checked birthdays in here with you guys?
No.
Okay, let's check birthdays. Who was born in January? Okay, we only have one January, so I don't have to check your day because you're not going to be close to anybody else. February birthdays. February birthdays, just one February birthday. That's okay. You're actually proving the point very well right now. March birthdays. Okay? 24. 24? 28. Okay, hold that thought. April. April birthdays. April birthdays. April? 28. 28? 5th? 1st? 20th? 20th. Interesting. May. Interesting or predictable? You think about this. Interesting or predictable? May. 5. 26.
22nd.
22nd. Interesting. 1. Was 5th over here? 5th. Oh. 20. 20. And there was a 22nd, I believe. Is that? 29. Yeah. 29. Okay. That was May. June. 28. Second. July. Anybody? Let's come back to that. July. 19. 16. 16. 3rd. Are you getting the point? Maybe not. August. August. 25. 14. 20th. September. You ever wonder why it's called September? It's the 9th month. Sept means 7. You ever wonder about that? You will now. September. Haley, you're the only one. No, there's 2. September. 8. 7.
Thanks, Sean.
Sitting next to you. Good. October. 8th month or 10th? I don't know. You decide. 4th. 16. 29. 21st. Okay, no matches there in October. November. 9 or 11? 16. Only one November. And then December. Only one December birthday with Amy. Now, I don't think about the month. December, 10, 12. There's a history lesson in there. So what happened? There's only like 30 people in the room, right? How many people would you have to have in the room to guarantee that at least 2 people have the same birthday? 30 people. To guarantee 366 or 67, depending if you want to count leap years or not. You'd have to have at least 366 people in the room to guarantee that you have a birthday match. Because theoretically speaking, it's possible. Amy was born January 1st. Callan, January 2nd. Carrie, January 3rd. Tammy, January 4th. Blake, January 5th. Possible, yes? So it's possible with 30 people, you were all born in the month of January in successive days. Possible, but not likely or probable. Well said. So, what's more likely?
So the odds increase the more you, the more data you have?
Definitely. The odds, the more people I have in the room. I was almost 95% sure we were going to have a birthday match in here before we even started. Because mathematically, randomness says, I think it's 20, if there's 25 people in the room, it's roughly a 50-50 shot. With each person above that, it goes up surprisingly quickly. If you have 40 people in a room, it's like a 90% chance. So I felt pretty good we had at least one match. We ended up having 3 matches in here, which is pretty slick. And a lot of close calls, 7 and 8 over here, remember that one? Here's the takeaway from randomness, and this is why, Tammy, you brought it up when you said, I got 3 of those right here. Randomness doesn't arrange itself evenly. It clumps. Random events tend to clump. Now, the clumping is something you can actually measure. I say clumping, they don't clump predictably. This is why people in Vegas make me laugh. This machine is due. It is? This machine is due. It is? The little lady sat there for 3.5 hours and didn't hit, and they're waiting for that seat. Because as soon as that lady gets up, they're going to jump into that seat. And I ask why? Because it's due. Do you know how to measure dueness? Because I just love walking through casinos, and it's comical. You ever seen the old cartoon? I can't find it anymore. I'll have to show it to you guys. Welcome to beautiful Las Vegas, generously funded by those who are bad at math. Because that really is the idea. The house always wins. That's what we're going to end this class learning about how the house always wins and how they control it so they always win. That's next week's lessons. But this is the beginning of it right here. And what just happened to Tammy is very hard to think about in a purely random fashion. As a matter of fact, it's predictable that somebody would have hits like that, just like it's predictable we were going to have birthday matches in this room. That doesn't mean it's easy to understand. Johnny Carson, the late great Johnny Carson. You remember Johnny Carson? Some of you do. Some of you do. He's like Conan before Conan, if you will, ish. Conan, Jon Stewart, but not quite political. Leno before Leno actually took Carson's place. He had a guest on his show once. Now, Carson has a studio of about 200 people, 200 guests behind him. And the guest came on and tried to explain that idea to Johnny Carson. This was back in the, I'm going to guess the 80s, maybe early 90s. Probably even before that, maybe. And Johnny didn't believe it. He's like, I don't believe it. He's like, my birthday's October 15th. Anybody in the audience have October 15th for a birthday? And nobody did. He's like, you see? It's crap. He didn't say crap. Johnny wouldn't say that. But he said, you see, I don't believe it, and I just proved that it's not right. But he didn't prove that it's not right. Because we proved that it's most likely right. Because I didn't go, who has their birthday on June 28th, which is mine? Nobody's going to raise their hands, right? Does that mean there isn't a birthday match in the room? No, it just means you don't match mine. Somewhere in the room, there's an almost, with 200 people in a room, it's like a 99.9999% chance that somebody in there matches somebody else. You just don't know who or which birthday. So, the fact that 3 of them settled on you while you were doing your data makes perfect sense. It's just a clump of that randomness happening right there. It's very hard for humans to process the idea that randomness does that clumping. Do you remember last week when I had you guys write on the board? Write 5 H's and T's as if you were simulating a coin flip. And nobody put down 4 H's and 1 T or 4 T's and 1 H. A couple of you put down 5 T's and 5 H's, which is pretty slick. I was pretty proud of that. But nobody put down 4 and 1. Now later on, we're going to flip coins, if we hopefully get to it today. We're going to flip coins and we're going to show you that that actually happens with fairly high probability. But you guys skipped right over it. Why? Because we suck at being random. Think about it. You showed up at 10:15 today. How unrandom is that? Right? And you'll stay till roughly noon, and then you'll leave. How unrandom? Random would be you show up here sometimes at 2:15 a.m. Wonder where the hell I am. Be pissed at me for not being random. Randomness is hard. Randomness is very hard. It's also amazingly important when you study statistics. So that's what we're looking at right now. I'm going to shut up now. But Tammy, you gave me the perfect opportunity to bridge it with the birthdays. It's almost predictable when you have enough trials that some of those clumps are going to occur. Just like when you flip a coin, isn't it you saw it happen to me. Ooh! You saw it happen to me last week. Was it last week? I think it was Monday of last week. I sat here and flipped tails like 9 times in a row. That's pretty rare. But if I do it enough times, it's going to happen. And how many times have I flipped coins? I'm 40 years old, and I've been teaching math for half of my life. How many coins have I flipped? Let's not think about that. That's depressing. So it's going to happen somewhere, yes? Yeah, maybe? You buying this? Okay, keep collecting data. I'm going to fix the spreadsheet so you can